Sometimes when you're doing Igcse physics, you'll be expected to give a description of how a step down or a step up transformer works. And in this case here, you need to be able to identify what a step down transformer is and how it functions. So, but basically, whatever we have here is what we call a step down transformer. And how did we know that? If you look at the number of turns in the primary coil and the number of turns in the secondary coil, you realize that we have more turns in the primary than in the secondary. So which means this is a step down transformer. We're going to define this as a type of transformer which reduces voltage, which means that you need also to understand how it works. So what are we going to say? In this part, we're going to say when AC current flows through the primary coil, magnetic fields are created. Which constantly change size and direction. Change size and direction are created. So that is the first concept you need to understand as far as the working of a transformer is concerned. So when alternating current flows through the primary coil here, it will create magnetic fields which are constantly change size and direction. So when those fields cut through the secondary coil, because we have a soft iron core here, and this soft iron core is going to link the field. You can see now I've drawn some dotted lines. So when the fields are created, those fields are going to be linked to this particular secondary coil. And what happens is that when the fields cut through the secondary coil, when the field cut through the secondary coil, an EMF is induced in the coil through electromagnetic induction. Through a process known as electromagnetic induction. So that is what you need to remember in this case. So which means that this alternating current that has been created, yeah, and we need to remember that since there are fewer turns, in the secondary coil, less EMF is induced. So basically, when we are talking about a step down transformer, it's meant to reduce the voltage, because when alternating current flows through the primary coil, it creates varying magnetic fields. And when these fields cut through the secondary coil, it means there will be an induced EMF in the secondary coil, which result to the flow of electric current. And the number of turns determines how much EMF is induced in the secondary coil. So equations that are important for this particular concept. Equations that are important in this particular concept is number of turns in the primary coil over number of turns in the secondary coil should be equal to the voltage in the primary coil over voltage in the secondary coil, which you can be able to use in order to work out a given question where you are maybe expected to find the missing voltage. For instance, here you can see we are having number of turns in the primary coil and the secondary coil at 500, in the primary coil at 1200. So which means we can be able to say in our calculation that 1200, which is the number of turns in the primary coil, over number of turns in the secondary coil, is that, which is 500, is going to be equivalent to voltage in the primary coil. You can see here is 15 volts, 15 over voltage in the secondary coil, which we don't know. So which will mean that if we, in the event we want to work out voltage in the secondary coil, it's going to be 15 times 500. If we divide that by 1200, we must have gotten the answer for that case. So I'll just take my calculator there, and then I'm going to say this is going to be what? This is going to be 15 times 500 over 1200, which means the answer is going to be 6.25. If we work it out, we are going to get our answer being equivalent to 6.25 volts. So this is the most important formula and the most important concept that you really ought to understand as far as this topic is concerned. The second formula that is important in this area, the second important formula that you must know in this concept here is power in is equals to power out. So that means power in the primary coil, power in is the power in the primary coil, should be equals to the power output. So that in the event maybe you are working out comparatively, you are given voltage and current for different sections, we can be able to say current in the primary coil times voltage in the primary coil should be equals to current in the secondary coil times voltage in the secondary coil. So which means you can now be able to use this formula in order to work out any question as far as the concept of transformers is concerned. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. In Proflan YouTube channels, I do maths and physics, pure math and A levels, and also I do Cambridge and Igcse. So consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. And need also to mention that if you have not joined our Patreon page, consider joining our Patreon page so that you can be able to download most of the PDF that we usually do in this particular video. You can be able to access the link in the description. I wish you all the best. If you're going to do the exam, good luck.